Welcome back to the last half of lesson 5.3. We are been talking about the binomial distribution, and now we're going to learn how to find some probabilities of the binomial distribution. We're going to have this particular notation here that says x can be distributed binomially with n number of trials and p probability. So we're going to use this in Desmos. Let's look at example 9. Example 9 says, it has been stated that 41% of adult workers have a high school diploma but do not pursue any further education. Let X be the number of workers who have a high school diploma but do not pursue any further education. So X could be 0 all the way through 10. The probability of success is 0.41, and that means the probability of failure is 0.59. And we are going to define X right here. X, and then this is the tilde symbol, B for binomial, 10 is N, and 0.41 is P. If 10 adult workers are randomly selected, find the probability that at most 6 of them have a high school diploma but do not pursue any further education. At most 6 means that we can have 0 all the way through 6. So it looks like this, the probability of X less than or equal to 6. Which means that we could take the individual probabilities like we did in chapter 4, find those and add them up. But that is going to be time consuming, so we're going to use Desmos. So Desmos has this command, binomial dist of n comma p. Make sure that you check the box for cumulative if you want to find a group of them together. And our minimum here would be 0, and we want it to go through 6. And you can see the ones that it included in the graph in Desmos because it's colors in the circles, 0, 1, 2, 3, 4, 5, and 6. And that comes out to be 0.9374. The y-axis is the probability of X, and X is the number of workers who have only a high school diploma. So B says, what is the number of adult workers that you expect to have a high school diploma but not pursue any further education? And so we're going to calculate that by N times P equals N, which is 10 times 0.41 or 4.1 workers. And the variance is sigma squared is equal to N times P times Q. And if we take the square root of that, we would get our standard deviation, which is 1.56. So out of 10 workers, we would expect 4.1 to only have a high school diploma, give or take 1.56. About 32% of students participate in a community volunteer program outside of school. If 30 students are selected at random, find the following. The probability that exactly 9 of them participate in a community volunteer program outside of school. So I'm writing it as probability of X equals 9. It's binomially distributed with N at 30 and P at 0.32. And I'm going to share my screen so you can see how we can do this in Desmos here. So here is the binomial of 30 comma 0.32. And if I just want to find 9 particular, I'm not going to check the box. I am going to turn this distribution on. Remember that over on the left, you can turn on and off your graphs. So if I turn this one back on, I go over here, I can click on where I think 9 is, and then it gives me the individual probability. Okay. Part B says the probability that at most 14 participate in a community volunteer program outside of school. So that means I'm going to include 14, and because it's cumulative, because any answer 0 through 14 will be part of the addition, I'm going to click on my cumulative. And so you can see there it's in purple. And it's going to add up all of the answers, 0. See all the ones that are filled in, 0 all the way up through 14. So all of these are added together, all of these probabilities here. Let's look at example 11. So example 11 says, in 2013, Jerry's Artorama Art Supplies catalog, there are 560 pages. 8 of these pages feature signature artists. Suppose we randomly sample 8 pages. Let X be the number of pages that feature signature artists. What values does X take on? So X could be anywhere from 0 to 8 if all of the pages happen to be signature artists. What is the probability distribution? So this is, it's either a signature artist or it's not. So it's binomial. And 8 is our N. And the probability of success is 8 out of 560. Find the following probabilities. The probability that 2 pages feature signature artists means we're looking for the probability of X equaling exactly 2. So binomial distribution, we're choosing from, we have 8 as our N. Our probability of them being signature artists are 8 out of 560. And then that is 0.0052 of them. What about number 2? It says the probability that at most 6 pages feature signature artists. So that's less than or equal to 6. So I'm going to show you in Desmos what that looks like. So in Desmos, I'm going to copy this. And I'm going to click on the cumulative because it said at most 6. So I'm going to go from 0 to 6. And that is, I'm going to turn off my purple distribution up here too. And then I'm going to use my there. So it's very likely that none of them, because right, there's 560 pages and only 8 of them are successfully signature artists anyway. So the likelihood of 0 through 6 of them being a successful artist is 0.9999, very high, almost 1. And then part 3 says, what is the probability that more than 3 pages feature signature artists? So that would be greater than 3. So I'm going to click on my cumulative, and greater than 3 means 4 or more. So my minimum is going to be 4 all the way up through 8. And so that would be 0.0001, 2, 3, 4, 5 zeros. Two 7. So it's very, very unlikely. So that one's very likely, almost confirmed 1. And this one is very unlikely. Then using the formulas, calculate the mean and standard deviation. So putting that into Desmos, N is 8 and P is 8 out of 560. Oops, this becomes 36 out of 560, which is 0.1143. And then the standard deviation is N times P times Q. And this should be an N right here. So 8 times 8 over 560 times 552 over 60 over 560. And this Desmos link to all the work that I'm showing you today is in Canvas as well. So you can see my work here in Desmos. Let's look at example 12. It says, according to a Gallup poll, 60% of American adults prefer saving over spending. X is the number of American adults out of a random sample of 50 who prefer saving to spending. What is the probability distribution for X? So X is considered binomial because they either do or do not prefer saving to spending. There are 50 of them, and the probability of success is 0.6. Use your calculator to find the following probabilities. The probability that 25 adults in the sample prefer saving over spending. And they didn't say more or less than, so we're going to look at exactly 25 of them. In Desmos, we are going to do our binomial of 50 times 0.6. And I'm going to share my screen. And because we're looking at exactly 25, I'm not going to check this box. I'm going to turn off my other picture. I'm going to hit the magnifying glass, and there they are. Wow. So I'm looking at 25, which is about right here. Oh, no, right here. So 25 is 0.04046. And then number 2 says the probability that at most 20 adults prefer saving. So at most means the probability that X is less than or equal to 20. So I'm going to copy this command and paste it. This time I am going to check the box. And so I'm going from 0 up through 20. And that is 0.00336. Number 3 says the probability that more than 30 adults prefer saving. So more than 30 would be X is greater than 30. So strictly greater than 30 is the same as greater than or equal to 31. So we could copy this last command and paste that. Make sure the box is checked. And that means we're going to start at 31 and go up to all 50 of them. We don't want to include 30 on this one. And then C says, use the formulas to calculate the mean and the standard deviation. So the mean is going to be N, which is 50, times the probability of P, which is 0.6. So on average, we would expect 30. I'll show you my paper in a minute. And our standard deviation is the square root of N times P times Q. That comes out to be 3.464. So let's share my paper so that you can see everything. And the last question says, explain the mean and standard deviation in context. Okay, when we're talking about the binomial, we also have to refer to the N. So out of 50 adults, we would expect 30 of them to prefer saving over spending. Give or take 3.464. Example 13 says the lifetime risk of developing pancreatic cancer is about 1 in 78 or 1.28%. Suppose we randomly sample 200 people. Let X be the number of people who will develop pancreatic cancer. What is the probability distribution for X? So X is binomial with N at 200 and P at 0.0128. Using the formulas, calculate the mean and standard deviation. So the mean is going to be 200 times 0.0128. And the standard deviation is the square root of 200 times 0.0128 times Q, which is 1 minus 0.0128. And using Desmos, we can find that that comes out to be 2.56 on average, and the standard deviation is 1.59. And then it says, use your calculator to find the probability that at most 8 people develop pancreatic cancer. So that would be the probability that at most, so less than or equal to 8. Okay, so we are going to put in hours and we said less than or equal to 8. So that would be 0.9988. And then D says, is it more likely that 5 or 6 people will develop pancreatic cancer? Justify your answer. So we want to look at 5, and then we want to look at 6. And I'm going to go up here and turn off these other graphs, by the way, since we don't need them. And look at my magnifying glass. Oops. The 5 or 6. I'm going to just kind of click on there's 1, there's 5. So 5 is 0.07065, and 6 is 0.02977. So it looks like 5 has a higher probability. So it's more likely that 5 out of the 200 would have pancreatic cancer. And the last example for, oh, no, we have 2 more. Sorry about that. Example 14, I should say. So during the 2016 regular NBA season, DeAndre Jordan of the LA Clippers had the highest field goal completion rate in the league. DeAndre scored 61.3% of his shots. Suppose you choose a random sample of 80 shots made by DeAndre during the 2013 season. X the number of shots that scored points. What is the probability of X? So it's either he scored points or he didn't. So X is binomial, and they sampled 80 shots, and his probability for success is 0.613. Using the formulas, calculate the mean and the standard deviation. So the mean is 49 when we round appropriately, and the standard deviation is 4.36. Use your calculator to find the probability that DeAndre scored 60 of these shots. Okay, share my screen here. So for number 14, we're going to use the binomial distribution. Of beauty and success is at 613. And we want to know if he scored 60. So we're looking at exactly 60. So I have to turn off my other graph and then hit the magnifying. So 60 is down here somewhere. Oh, I got it. 0.00355. So the probability of exactly 60 of the 80 shots is 0.00355. And then D says, find the probability that DeAndre scored with more than 50 of these shots. So the probability that X is greater than 50. So I'm going to copy that. And then more than 50 means I'm going to use the cumulative. And I'm going to go from 50 up to 80. And that probability is 0.3718. Now for our last example for lesson 3 before the midterm last lesson. So it's going back to our intro example to lesson 5.3. The probability of an NBA player making a single free throw is 83%. This is going back to the beginning of chapter 5, I should say, where we made a tree diagram of all the outcomes. Let X be the number of free throws made by the NBA player, use the binomial distribution in Desmos. So X is a binomial distribution, and we have 3 shots, N is 3, and his likelihood is 0.83. And we're going to turn on, we're going to leave it with our individual ones. And this is okay. And I'm going to hit the magnifying glass. Again, so there we go. So there's 0 made, 1 made, 2 made, or 3 made. Right there it is. There's the individuals. So just like what we came up with before. So 0.0049, 0.072, 0.3513, and 0.5718. And that wraps up chapter 5. Watch me back for some more videos.